Geometry, hello, good afternoon. We're going over the practice test for your placement test, which you'll be taking tomorrow morning at 9, or the makeup day is Wednesday. If you can't make that, then you'll need to work out with TG what day works best for you. So you got a letter with the rules and stuff. What did they say about calculators? You can't bring one, or you can't use one? They'll provide you one? Okay. Because I would assume, like for the sine, cosine, tangent, and stuff like that, that they would want you to use a calculator. So just make sure it's in degree mode when you get it. They should all be, but just make sure so you don't get questions wrong because of that. I do know it's multiple choice, which multiple choice tests are great because you only have a set number of options, and there are usually one or two that you can eliminate just for sure because they make absolutely no sense. If you don't know something, don't just guess. Eliminate first, and then guess from there. Yeah.
How do you put it in degree mode, like if it's not?
If it's not in degree mode, there should be like a mode button. Do you have your calculators out? Who's got a calculator for this class, which is probably the one you get? So, yeah. On the recommended calculator for the course, right next to the second function button, it says DRG. If you press that, you'll see in the bottom right corner of your screen, actually it gives you the option. It says DEG, RAD, or GRD. Just make sure it's selected DEG, which also shows up in the bottom right corner of your display. So if it's not on that, I forgot you carry an extra calculator with you. If it's not on that, then just put it there. And if you don't know, you can ask them to verify too. Yeah. I do not know. I don't know how many questions it is. This packet didn't come from TG, but I've been doing this long enough to know that the questions on it are going to be similar to what's on the TG test. Yes? You want it on DEG. It might say DRG. That's probably fine too. Okay? You just don't want it on GRD. That's not what you want. Okay, so like I said, multiple choice, which is great because it means that you get to eliminate obviously wrong answers and kind of work your way down to at least an educated guess. They know that you have not covered circles, so we're going to talk about the circle ones today. And if you get those right on the test, that's just a bonus, but they know going in you haven't covered those yet. They did say they will provide some formulas. They would not tell me which ones. So go in knowing the main ones: midpoint formula, distance formula, Pythagorean theorem, the special right triangle relationships, your areas, things like that. And whatever you get, great. And if you don't get something, then just do the best you can. So the format is we're going to kind of go through not every question. I've highlighted some that I know that I want to talk about. If there are any others that you want to talk about, you have the answer key. You've had the answer key the entire time. If there's one that you got wrong, not sure why it's wrong, and want to talk about it, then we can do that. But so any questions on the first few here? They're all kind of logic-based questions, kind of reasoning questions. You've got patterns. You've got deductive reasoning. Anything from the first couple? All right, I'll just mention a number, and if there's one you want to talk about before that, stop me. I want to bring up number 5. You probably have had Venn diagrams before. I trust at some point. We just haven't talked about them specifically this year. So who can tell me how a Venn diagram works? How do you read it? How do you interpret it? Linnea?
They're kind of like comparing all of the things, and so if it's more towards one side, then it's like, for example, like the tennis, it has 2, but then there's also 7 people that are doing soccer 2, and 3 people that are doing basketball, and 5 people that are doing all 3.
Right, yeah. So it's a way to kind of compare things both as individual and as overlapping. So as Linnea said, there are 2 people that play only tennis because that 2 is in a circle by itself. There are 7 people that play tennis and soccer because that 7 is part of both the tennis and the soccer circle. And there are 5 people that play all 3 because that 5 is a part of all 3 circles. Okay, so a question that you might get from this year, how many students play basketball or soccer? Basketball or soccer. What did you put down for this? I mean, you might think the answer is 12 because 8 and 4 there, but then that 1, right? 13 students. Yes, Sebastian.
28.
28. Why 28?
Because, so soccer and basketball, so we know that it's 8 plus 4, which is 12 right away.
It's not 28, actually.
It is. And then you have that 1 for equals, right? So that's 13. And then you have the 7 and the 3, which is 10. So that makes it 23. Then you got the 5, because that's like how many can play all of them, so then you get 28.
So reading the question here is pretty important, right? How many students play basketball or soccer? So we want all of the basketball players and all of the soccer players, which the way that this Venn diagram is divided up, there are 4 numbers in the basketball circle. 4 play just basketball, 1 plays basketball and soccer only, 3 play basketball and tennis only, and 5 play all 3. Okay, and then for the soccer, you have 8 that play soccer only, 1 for basketball and soccer, 7 for soccer and tennis, and 5 that play all 3. So for how many students play basketball or soccer, you do want every number that is in a basketball or soccer circle. And thus, we do get 28. Okay. If the question was, how many students play basketball and soccer, that changes things drastically. Because how many students play basketball and soccer?
5.
Where do you get 5?
The middle.
The middle? What about the 1?
Oh, yeah, 6.
Okay, so 6, right? 6 plays basketball and soccer. 5 of those also play tennis, but 6 total plays basketball and soccer. So if you get a question on a Venn diagram, it's not, quote unquote, in geometry. I mean, it's a part of the representation and the logic piece. But if you do, then pay very close attention to the question being asked. Okay, and again, eliminate the obvious misanswers. How do you get 34 or 36? You include tennis. You can narrow it down there. Okay. Let's see. The next couple are on inverse, converse, conditional statements. That's the if that, then this, if not that, then not this stuff. Then it gets into transversals and parallel lines. So you want to know those relationships, the corresponding angles, consecutive interior angles, alternate exterior angles, all that sort of stuff. Did you have any issues on questions through number 16? They're all kind of similar, either the converse, inverse stuff, or the transversals with parallel lines. Anybody? Okay. Then starting in 17, it gets into stuff like, what makes the lines parallel. Number 17, you have to kind of set up an equation to look at, well, I guess you would need an equation, but supplementary angles. Any? I highlighted on my packet question number 19. I don't remember why off the top of my head, but let's take a look at it. At least they give you lots of space to work in this packet here. My goodness. Oof. So 19 says the measures of 2 complementary angles are 2x plus 2 and 3x minus 5. What is the measure of the smaller angle? I don't remember why I highlighted this. I've got a question similar to this on one of the practice work pages, and it's one that students oftentimes get incorrect. So how would you set this up here? How would you set this up? Sebastian?
You can use either equation in parentheses, and then you can pick one of the 4 options. And then once you get what x equals, you plug that into the other equation to see if that one works too. But if it doesn't, then it's either too big or too small.
The beauty of a multiple choice test, right? Sebastian nailed it here. Yeah. If you don't know how to set it up, I mean, one of these 4 is the answer. Okay. So if you're not sure how to set up the equation, start with letter A, plug it into each of them, and see what happens. What should you get when you plug in a value in for x here and combine the 2 angles together? 90. And how do you know that? because it's complementary, which means they add up to 90. So there is a bit of needed knowledge here. You have to know what that word means. But if you're unsure how to set it up, yes, guess and check on a multiple choice test. Fantastic. If it's a timed test tomorrow, which did they say it was timed? An hour and a half. So then you got to be careful, right? You might want to go through the entire test, answer every question that you just know to get as many questions answered as you can, and then go back and kind of work through, because you wouldn't want to spend 10 minutes on one question, right? When there's a whole test after that. So go through the test first, answer what you know, then go back and tackle this. So how would you set this up more mathematically then? Let's look at it the more efficient way other than guessing and checking. If we know these two angles have to add to be 90, what's the relationship that we can write with these angles here? Emily.
5x minus 3 equals 90.
Right, if you combine them, so you got 2x plus 2 plus 3x minus 5. If you combine like terms, 5x minus 3 equals 90. You solve that, you get 93 divided by 5, which is 18.6. Okay, so that's your value for x. And it says, what is the measure of the smaller angle? Now, if I was running this test, I would make one of my answer options 18.6, right? Because what I would want you to know is that solving for x isn't always the answer. It's what do you do with that? What's the actual question? The question is, what is the measure of the smaller angle? So if we plug in 18.6 into 2x plus 2 and plug in 18.6 into 3x minus 5, you get those values, and then the smaller of the two would be your answer, which is B, I think. Yeah. Okay. All right. So that's why I want to bring that one up. And Sebastian brought up a great point. If you don't know how to set it up, you have 4 answers here. Start kind of working with it and see what happens. Okay. Questions on that? All right. Anybody have any questions on anything after that? It kind of gets into to properties of shapes then, which one of your con assignments is for this week actually. How many sides a heptagon has? Yes, McKenna. 26. 26. Oop. All right. In terms of x, what is the measure of angle S? What's your question on this one?
I thought it was B, but it's D.
Okay. So what do we know about triangles, first of all, as particularly angles? Sebastian.
The interior angles have to be 180.
Okay. So far, what do we have represented here? We have angle R, which is 3x plus 4, and angle T, which is 4x minus 10. Now, we don't know what that third angle is, okay? We aren't given any information about it. We don't know whether this triangle is isosceles or equilateral or anything like that. So, McKenna, how did you come up with you said B originally?
Yeah, well, I just put the 2 angles together.
Okay.
I didn't really spend that much time.
Okay, sure, yeah. Okay, so what we have together here, and that's actually the right move to start with, if we combine like terms, add these angles together, we get a total of 7x minus 6. Okay? Yeah.
Oh, I'm going to say what we meant.
Oh, sure.
Well, what I did is I did that, and then if we need to get those 2 angles figured out to get the last one, I do that 7x minus 6 equals 120.
Why 120?
Because then you get those 2 angles figured out, and then I guess
But where does the 120 come from? How do you know it's 120?
2 angles, no matter what triangle it is going to add up to 120.
No.
Only if the third angle equals 60,
Oh, yeah.
right? Only if the third angle equals 60. Okay, so let's label this angle N here, right? Just because my S's look like 5s. Let's label it angle N. What we know is that 7x minus 6, which is the sum of angles R and T, plus that third angle plus n equals 180, right? The three angles of the triangle have to be 180. So we have the sum of the first two represented at 7x minus 6, and plus that third one equals 180. And what we're looking for here is in terms of x, okay? Which means we want to get n by itself. And our measure of the angle, we're going to have an x in there. So what are we going to do to this equation to get n by itself? Isolate n. Julia? Add 6. Okay, so we have 7x plus n equals 186. And then subtract 7x from both sides. And we get that third angle, whatever it is equal to 186 minus 7x. Okay, which is the answer for letter D. Right? So then once we figure out what x is, we get more information or whatever, right? Then we can plug that in to solve for n. Okay? Questions on that one now? Good? Okay. After that, we get into, diagonal's a rectangle. Diagonal's a rectangle again. I assume that hopefully went pretty well considering it's our current unit.
Can I ask about 31?
31? Sure. 29, 30, yes. What's your question on that?
I don't specifically have a question. I'm just wondering.
Okay. So before we get to 31, just know your properties for quadrilaterals. This one, let's see, it says the diagonal from P to R is 100, and it's asking for the diagonal from Q to S. So knowing the diagonals are congruent, because it's a rectangle, that's the knowledge there. This one, for rectangle RSTU, what is the length of HT? So for this one, you'd need to use Pythagorean Theorem, right, to get the diagonal there. And it's asking for HT, which is going to be half of that side, based on the properties of a rectangle. So all those things that we've talked about, this unit, very prevalent here. Okay. 31 though, Susan's circular swimming pool has an area of 314 square feet. What is the approximate diameter of the pool? And here's where they gave you a formula. Like I said, I don't know if this is going to be on the test tomorrow or not, but we've used circles enough this year where hopefully you know what that formula for the area of a circle is. So if we know the formula and we know that her pool's area is 314, we can come up with that relationship, right? 314 is equal to pi r squared. And then we're looking for the diameter. So what are we going to do, Sebastian?
If you have 300 square feet, so we know that what one of the variables is, which is pi, so it's 314 equals pi, so you just divide by pi on both sides. Okay,
and that's going to give us 100, because it does say use 3.14 for pi. So 100 equals r squared.
And then you rip both of the sides.
So 10 equals r.
And that's just half of the diameter, because that's the radius. So then you multiply that by
Yes, this is where I would have done this too if I wrote this test. 10 is an answer here because you need to make sure that you understand what you're solving for. We solved for the radius. It wants the diameter, and so the radius being 10, the diameter is going to double that. Okay. If they did not provide the formula, you don't know how to set this up or whatever, knowing that these four options represent the diameter of the pool, what you could do is take half of each of them and plug them in. I suppose you'd have to know the formula to do this, but plug them in the formula and see which one gets you an area of about 314. So there's another example where a multiple choice test is helpful in that you can kind of narrow down, wrong answers here. Okay, Leanne, yes? No, Emily, yes for that one? Is that good? Yeah. Okay. So going on then, 32, it says shaded figure, but I don't see any shading, but we'll just assume it's something like this. So hopefully that went well. You've been doing that in your math packet all year long. I did highlight number 33. Yeah. Some of you probably read this one and said, oh, nope, it's only one. I'll just move on. But let's stop to kind of talk about this, because every point you can get on this test is going to be worth your time. This is a question where I'd probably save until the very end. It looks like it's going to be a lot of work. If I don't really understand how to do it, I'd save it. But if I got to it, great. It says 4 circular parks of different sizes are to be surrounded with fence. Park 1 has half the diameter of Park 2, 1/3 the diameter of Park 3, 1/4 the diameter of Park 4. If one bundle of fence exactly surrounds Park 2, how many bundles of fence will be used in this project? Okay, so let's draw our circle here, and we'll label this Park 1 and then Park 2. I'm going to make them all the same size, just because I don't want to try and mess with accuracy here. Okay, and it says Park 1 has half the diameter of Park 2, 1/3 the diameter of Park 3, and 1/4 the diameter of Park 4. Since Park 1 is related to all other parks, let's label the Park 1 has half the diameter. Okay, let's label Park 1 the diameter x. Okay, since it's related to all other parks, let's make our easiest one our base value here. So if this one is half the diameter of Park 2, what's the diameter of Park 2? 2x. Okay, and if Park 1 is 1/3 the diameter of Park 3, what's the diameter of Park 3? 3x. And if Park 1 is 1/4 the diameter of Park 4, what's the diameter of Park 4? 4x. Okay? And you know, labeling this a variable and one that's easy to work with because it relates to all others, that's the good place to start here. And then it says one bundle of fence exactly surrounds Park 2. So we need to kind of know if the relationship here, if one bundle surrounds Park 2, does that mean that we only need half a bundle for Park 1? What's the relationship of the circumferences here? What's the formula for circumference of a circle? 2 pi r, or, since we're talking about diameters, pi times d, right? And so the diameter of Park 2 is equal to 2x, so we can say that this is going to need pi times 2x. Right?
Hello, teacher.
Okay, so just to recap here, we're talking about the distance around each park, so circumference. The formula for circumference is pi times the diameter. If the diameter of Park 2 we've identified as 2x, then the value of the circumference is pi times 2x, right? Follow me? Okay, what formula or what expression can we write to represent the diameter of Park 1?
What I did was, if 2, it'd be 2x. What I did was 2x equals 1 to find out what x equaled.
Okay. So then you got x equals 2? Setting it up like that, or?
2x equals 1. Or wait, no, that's not what I did.
Or did you pi 2x equals 1? For how many bundles?
Well, I didn't really do that. I realized that if 2x had one bundle, then x would have to equal half, 2.5, and then basically I just inserted that for x and I got 5.
So let's hold that for right now. Okay. What would the expression be for circle 1 to find the circumference, or Park 1? The circumference of Park 1. What's the expression? Don't pay attention to any of this. Just what's the expression here? Pi times x, right? Because it's pi times the diameter, so pi times x. Which, pi times 2x is double that, isn't it? What would the expression be for this park here? Pi times 3x. And the expression for Park 4? pi times 4x. So Linnea's strategy, because the way these are all written out, Park 1 is half of Park 2. So if this takes one bundle, this will take half of one. Park 3 is literally 3 times that. The only difference is that we're multiplying by 3 for the circumference of Park 3. So how many bundles will Park 3 take? 1.5. Park 4 is literally 4 times Park 1, because the only difference in their formulas for circumference is we're multiplying Park 4 by 4. So how many bundles will that take? 2. And we see that relationship here between parks 2 and 4. Park 4 is just double Park 2, right? Pi times 2x, pi times 4x, pi times 4x is double that. So total looks like we've got 3, 4, 5 bundles, letter B. Okay. Does that sit all right with people? Kind of, okay. All right. Let's see what we got here. What else we got? 34, 35, 36 all have to do with similarity and congruency, kind of corresponding parts. So you know your side, angle, HL, all that stuff. The next one I have highlighted is 46, just because that's the first circle diagram question. Anyone have one before 46 they want to talk about? Julia? 37. Oh, I keep forgetting to put that marker down. 37, 34, 35, 36, 37. I read this question. I thought, what a horrible play area. Like, literally, 12 feet, that's like 2 of me. That's nothing. And this weird, I don't know. Anyway, Chris is planning a play area shaped like this polygon. She draws a model similar to the desired play area. If the length of the longest side of her model is 33 centimeters, what is the length of the shortest side of the model? So its label, it's also clear which side of this is the longest side. That's the 44, right? So if she draws a model to this, and I'm just going to kind of try and something like that, okay? The length of the longest side on her model is 33. So what's the scale factor here? What's the relationship between these two figures? And the fact that it's a model tells you that it's going to be proportional. It'll be similar, right? So what's the relationship? What's the scale factor between these two figures? Sebastian? So, right, her model is 3/4 the size of the original. Okay? So the question is, what is the length of the shortest side of the model? The shortest side of the original is 12. Her model is 3/4 of that. So what is 3/4 of 12? 9. Okay? Using proportions, you could set it up, long side over long side equals short side over x, and use cross products or whatever to solve this here. But yeah. Okay, Julia? Comparing the relationship between 44 and 33, how do we get from, if we compare 33 to 44 and we simplify that fraction, it equals 3/4, which means that her model is 3/4 the size of the original. If we put the 44 up on top over 33 and simplify that, we get 4/3, meaning that her original is 4/3 the size of the model. Okay, but since the question is, what is the shortest side? That's why we kind of went to compare her model to the original. It's 3/4 of that, because we know the short side of the original, 3/4 of that is how I got 12. But is it matching up those corresponding sides? Okay. Okay. Any others before 46? Okay. So 46 is where we get to circles. And we have not talked about circles yet. I was pleased to see that a lot of the formulas were provided for you. And I think they will be provided for you on the test as well. And so more or less how to read them here. But it says the center of this circle is H. What is the measure of arc RS? This little hat here refers to arc. You know, geometry has all those symbols, different symbol for line, for segment, for array, for an angle. This curved thing over R and S means arc RS, which means it's looking for the measure on the circle, that arc, from R to S. Okay? Now, how many degrees are in a circle? 360. The way a circle works is that when you have what's called a central angle or an angle coming from the center, the measure of that angle is equal to the arc measure. Right? When the angle's coming from the center of the circle, the center of that angle measure is equal to the arc measure. So this one would be C60. Okay? If you can remember that, you should pick up 1 or 2 points on the test. That's the easiest one to remember. It's just from the center, whatever the angle measure is, the arc equals that. If you were given the arc measure, if you were told the arc was 60 and asked to find the angle, if it's an angle from the center of the circle, it's going to be equal. Right? Questions on that one? Okay. 47, similar thing here. We've got the center of the circle is P. And it says the length of PT is 5 centimeters. What is the measure of RPT? And here it gives you a formula. Again, I would expect this formula would be on the test for you. So what would you do if you're provided the formula here? It's a gift. Sebastian?
You do 1.25 pi over 2 pi r.
So you're just plugging the values you know, right? If this is the formula, you look at the picture here and you say, okay, the arc length of AB here over 2 pi r is equal to the measure of AB over 360. So let's apply that here. The AB that they're talking about is this TR part here, which is 1.25 pi. So the arc length of AB, or TR, 1.25 pi, divided by 2 pi r, equals the measure of AB over 360, which again, 1.25 pi over 360. And since pi is an actual value, right, you can use cross products to solve that. And did you solve this one? What did you come up with? Anyone? Emily? 45 degrees. Which one can you automatically eliminate of the 4 options here? 90, right? Because 90 would be a right angle. Clearly, it's not a right angle, right? You can also fairly safely eliminate 67.5. It certainly doesn't look like a 67-degree angle. And furthermore, if I were to create a right angle with RP in there, what do I notice about TP there? It's half, right? So there you get your 45 that way too. So play with it a little bit. Use clues. If they don't give you the formula, look at your answer and say which one doesn't make any sense, which one makes the most sense, and you can get it there. The next one, 48, I think I did like 5 in a row here. So 48 looks like this. It says the center of the circle is H. What is the measure of angle RST? So RST is this angle here. We're looking for this. let's eliminate what we know we can eliminate. What can we take out of this immediately? Colin? 100's gone. 100 is an obtuse angle. Clearly that is not an obtuse angle. It's not close to 100. What else can we safely eliminate? Julia? 75. We're already down into 2 options here. I heard someone say it's half. Who said that? Okay, and did you know that, or how did you?
I just kind of like looked at both the angles and saw that it looked smaller, and so when 25 was the only option smaller, then.
Yeah, you're absolutely right. Okay, when you've got an angle on the arc of a circle, its relationship is going to be half the measure of the arc it intersects. So we know that the arc length of RT is what? 50, because H, which is the center of the circle, remember these 2 measures match. The measure of the angle from the center matches the arc length. Okay, so you know that RT is 50. The mathematical relationship here is that RST, which starts on the other side of the circle and goes all the way across, that angle measure is half of the arc length. So 25 would be the correct answer. Now, going into the test not knowing that, or taking this test not knowing that, McKenna was still able to figure that out using logic. You do the same thing. Okay, but the mathematical relationship is an angle measure going across the circle such as that is half the length of the arc that it creates. Okay. 49. Let's look at this logically here. In this circle, H is the center and WXH is an equiangular triangle. Equiangular triangle. So all measures equal 60. What is the measure of WYX? Now, when you've got 3 letters here, it means you're going from W through Y all the way up to X. If you only have 2 letters, like we saw in previous ones, it's the most direct path. But if you want to go the other way, you need a 3rd letter, which means you're going from W through Y and all the way up to X. That's a big arc, isn't it? It's almost the whole circle. We know a circle is 360. That arc is almost the whole thing. We can definitely eliminate 60. We can definitely eliminate 120. 300 and 320 are pretty close. Which one is it and why? Linnea?
It's C,
Why?
because
The answer said that.
the answer.
Yes, good. Unfortunately, tomorrow they will not provide you the answer key. That much I know for sure.
I guess.
I know.
Yeah.
Julia?
WX is 60.
How do you know that WX is 60?
Because it's opposite from angle H.
And how do you know that angle H is 60? It's an equiangular triangle. So every angle in this triangle equals 60 degrees. Arc WX is the arc formed by angle H, which means the arc length is 60. And if you subtract 60 from 360, which is the measure of the circle, then you've got 300 degrees left. Okay? Can you see why circles are my favorite shape? They're so cool. Right? So cool. The next one, we start getting into chords and secants and tangents and segments within circle. These are admittedly a little more challenging. And so again, they're going to probably have the formulas on the test for you. If they don't, then you're not going to memorize them all before tomorrow morning at 9 a.m. So just take your best shot at it. But chords RT and WS intersect at point H in the circle. Notice point H is not in the center. So this angle measure is not going to be 40. And this angle measure is not going to be 110. Okay? That relationship only exists when H is in the center of the circle. So what is the relationship here? Okay. We're looking for it says here, the measure of angle AEC. So this angle here, AEC, is equal to half the measure of arc AC plus the measure of arc DB. AC is here, DB is here. So essentially, that angle is half the sum of the arcs that it and its vertical angle create. So applying that up to here, if we're looking for RHW, which RHW is right here, that's going to be half the sum of the arcs it and its vertical angle create. Okay, so what should the answer be?
B.
B, 75.
I did that without even.
Again, right? You don't know the formula, but you can look at this and you can be a little bit logical. Obviously, RHW is not an obtuse angle. So all of our obtuse angles can be eliminated. Okay? If you remember that any angle from the center is equal to the arc measure, well, the fact that H isn't in the center means it can't be 40. So that's gone too. And it leaves only one answer. Right? So logically, you can at least narrow it down to two answers and then guess from there, or using prior knowledge, you can get to the spot you want. Okay? Because you're not going to memorize this for tomorrow. And so logic is the way to go here. And any point, like I said, any point you can pick up on the test is a good point. As long as you don't get penalized for wrong answers, you should leave no question blank, ever, on a test. If you don't get penalized for wrong answers, you should never leave a question blank. If you've got 3 minutes left, guess, 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 guess. Right? What? Yeah, what?
Do we get penalized?
I don't know. So that's something to ask beforehand. Okay? I don't think so, but it's something to ask beforehand. Okay? Sure. Yeah. Same thing for a couple of years from now when you take the ACT test. No questions left blank unless they take points off for wrong answer. They didn't when I took it, so I don't know if they do it now or not. Okay, next one. You said this one was easy?
Yeah.
Based on the logic?
Yeah.
Okay.
Yeah, or just.
Yeah. The thing to know here, the piece of knowledge needed, is that when you've got a radius, which HY is, and what's called a tangent line, which is a line that intersects just the outside of the circle, doesn't pass through it at all, a tangent line and a radius create a right angle. So that's important. And then where'd you go from here? McKenna.
So I did 180 minus 125 to find like the inside of x, I guess.
Yep.
And then you just do 90 plus 55 and then subtract that.
And did you know that was a right angle or did you just kind of assume?
I just like figured it was.
Okay. I've always said from the start, it's dangerous to assume things in geometry. In this case, it would be okay, all right, because it's a placement test and you just got to put an answer on there. So using linear pair here, you know that 55 is the angle there. You see that triangle HXY. If you know Y is a right angle, it makes it even easier. If you don't, it looks like it, so go ahead and assume it, especially given the four answers that you have here. This is clearly not an obtuse angle, clearly not a right angle. You're left with 35 or 25. Maybe you guess between the two, but 35 would be the correct answer there. Okay? You should almost always be able to eliminate two of the answers. Let's see, what comes next? And then 51, 52, similar things. I mean, we can go over, you know, all the circle questions in detail, but like I said, you're not going to memorize these for tomorrow anyway. So taking a look at what we have here, chords RT and WS intersect at point H in the circle. Look at the length of what you're trying to find, HS there. Can we safely eliminate 5? Can we safely eliminate 4? So we're left with 2 or 2.5. I mean, it looks like it might be congruent to HT, okay? But then you go down here and you look at the relationship. It says AE times EB. So the part times the part equals CE times ED. The part times the part equals the part times the part. Applying that up here, it means that x times x plus 3 the part times the part is equal to 4 times 2.5. The part times the part. Okay? And if you don't want to do the math here because you recognize what type of equation do we have here? Is it going to be a linear or a quadratic graph? Linear slope-intercept form, quadratic, y equals ax squared plus bx plus c. Quadratic. And we see that because when we distribute that x into that parentheses, what are we getting? X squared, right? So what you could do, if you've narrowed it down just to these two options here, you know that 4 times 2.5 equals 10. What value for x makes this equal 10? If you plug in 2, you get 2 times 5. That equals 10. If you plug in 2.5, you get 2.5 times 5.5. That doesn't equal 10, right? So if you can kind of follow, if they give you the formula, you kind of follow along a little bit. You can get there at the very least. You narrow it down to 2 of them, and from there you can guess. But there you have it. Okay. In this case, guessing and checking was a big time saver over actually solving this. So, all right. Next one, another circle one, I believe. The measure of arc RT is 80. And we're looking for the measure of RST. Okay. RST looks pretty big. What can we eliminate, though? Sebastian?
160.
Why 160?
I don't know.
Oh, Julia, why 160? Yeah, 180 is a straight line. Okay, 160 is a very big angle. Clearly that's an obtuse. This one, maybe it looks a little bit obtuse. It looks a little bit bigger than a 90-degree angle, so we can probably assume this is going to be the kind of one that I'm guessing here, just based off the looks of it. But the formula, ADC, which is the angle outside of the circle, that's what we're trying to find here. The angle outside of the circle is equal to half the big angle, or the big arc, minus the small arc. Okay? Half the big arc minus the small arc. If this small arc is 80, what does the big arc equal? 280, right? Because 80 plus 280 equals 360. So if the outside angle there, ADC, or in our case RST, is half the difference of the big and the small, 280 minus 80 is 200. Half of that, we were right, 100. But again, logic got us there a lot faster. Okay, I think, that's the last circle one anyway. So for the circles, just do your best. You might be able to pick up on them. Or did I skip a page?
No.
Okay. What was 53? Oh, it was that one. Oh, I didn't flip. Okay, never mind. Sorry. Anything else that popped up? Then you get into right triangles. We have Pythagorean triple here, 5, 12, 13. Maybe you recognize that. Probably use Pythagorean theorem instead. 55, you have side lengths to make an obtuse triangle. We use the Pythagorean theorem for that too. We have some 30, 60, 90 triangles.
For the first 3 triangles, they're all the same number.
It's because they work out evenly.
What number are we on?
We're kind of working through after 54, and I've got 59 highlighted next. Is that one that you had? Yeah. So anything through 59?
Nope.
Okay. I highlighted 59 because we have not talked about roots yet. We will shortly. But it says, in radical form, what is the perimeter of this trapezoid? You should be able to fill in these missing sides here based on what we know. Since this is a rectangle here in the middle, you should be able to fill in that bottom section as being 8. We've got a 45, 45, 90 triangle. So what's the value of that hypotenuse? Sebastian?
6. root 2.
6 root 2, right? N and n root 2 for a 45, 45, 90 triangle. Which means that this height of this triangle is what? 6, which is important because that means that this side is 6, which is what we need to use to get the 30, 60, 90 triangle relationships here. What's the length of the hypotenuse of this 30, 60, 90 triangle if that short leg is 6? Nope, 6 root 3 is the long leg. That'll be this down here. The hypotenuse, 12, double that. Okay, so we can use our knowledge of triangles and rectangles and things to get that far. And then in radical form, what is the perimeter? We're looking at, I'll erase what we don't want. We don't want these 6s as far as our final perimeter. So you notice we have 12, 8, 8, and 6. That combines to give us 34. And then what do we have left? A 6 root 2 and a 6 root 3. Here's a 34 plus a 6 root 2 and a 6 root 3. Okay? The other option you could do is to calculate the decimal value of 6 root 2 and the decimal value of 6 root 3 and add them into our other side lengths, and then type this expression in your calculator and see which one matches. Okay, you could do that too. But if you recognize the whole numbers that we have here, combine them together, and then you see, oh, I've got a 6 root 2 and a 6 root 3 left over. I've got that there too. That must be it. Right? Okay, that one. Other questions? We get into some Pythagorean Theorem. I highlighted 64 and 65 being those, I keep hitting that, those polyhedron things, just because we haven't talked about a 3D shape such as these. But did you have any issues with these? How do you know it's a hexagonal prism? Because it got 6 sides. How do you know it's a prism, not a pyramid? Because it's not a pyramid, right? There's no point to it. 65, what is the sum of the number of faces, edges, and vertices for an octagonal prism? We've talked about faces before in surface area, right? It's kind of all the sides. The edges, are these pieces here. There's an edge, there's an edge, there's an edge, there's an edge, kind of all the lines or the segments that make up the shape. And then what's a vertice here? Emily? Where the edges meet. So every point. There's a point there, point there, point there, point there. So basically, you just got to kind of count up all the faces, all the edges, and all the vertices. There is a formula to help you find this. Again, you're not going to memorize it before tomorrow at 9 a.m. So the other way is to just do it. Just count them all up. Other than that, we get into surface area stuff, which you've been dealing with in your math packets. So if you've been doing those, then you should have an idea for that. Get into some volume stuff. Again, we've been doing that in the math packets. So that might have been the last one that I identified. We talk about parallel and perpendicular lines starting in question 81. We have the distance formula on there as well. Starting with question 88, where we talk about reflections and things like that. You have had these before in probably 5th and 6th grade, and so you might recognize some of the verbiage. Oh, geez.
Wait, can you do a question?
You can just go to the hardest tab.
Can you do 81?
That's kind of where you are.
What?
Can you do 81?
Just tap the screen. Tap the screen. Oh, no.
Hold on, I'm going back to 81 here. Where's the scroll bar? Okay. What is the slope of a line parallel?
Just kidding, just kidding.
Oh,
80.
80.
Yeah, I know, but I was
Oh, yeah. This one isn't going to fit on one page, but okay. So 80 says, which set shows the front, right, and top views of this three-dimensional figure? So this is kind of like a kind of like drawing the net of the figures for surface area, also kind of the polynomial questions. How do things kind of visualize where they fit? So what it's saying is that if you were to take this object, which is kind of like this not quite rectangular prism with a cylinder up on top, and you set it in front of you, you looked at it from the front, what's it going to look like? Okay, and the front side is labeled here. So is it going to look like this? Oh, geez, Louise. This with that little cylinder up on the left side, which is your, or is it going to be on the right side? So if you look at this from the front, is that cylinder going to be on the left or the right side of it? The left side, right? If this is the front, it's going to be on that left side. So you can eliminate C and D. So we'll just focus on A and B here. And then the next one that stands out to me, from the top, you look straight down on it. Is that cylinder going to be on the left corner, top corner, or the right top corner? Left top corner. So that's got that one too. That one's different, so it's got to be A. And you can verify it if you look at it from the right, which is from this side, right? That cylinder from the right is on that right side there. So it's just different viewpoints of an object, okay? So then, 88, that's where I was at. Where's the scroll bar that you speak of, Sebastian?
Well, is this in PowerPoint or Word or what is
This is Adobe Flash. No, not Flash. No, what's it? PDF. Not Adobe. PDF. Adobe, yeah, that got cut, didn't it? Okay, so this is where we start with the translations and rotations and things like that. Like I said, you've talked about this before. It's probably been a couple of years, but it says how many units down would triangle RST need to be translated in order for the coordinates of R to be -3, 0. You see this R prime. We've talked about that before when we did dilations back in CO38. But point R, it's right here. For it to be at -3, 0, how far down is that? 5 units down. Okay, so even without talking about it, you can kind of look at it, and if you think about it, you can probably figure it out. So, and that's true for the rest of them too. I think all the way through 90, 91. But okay, I hope you feel confident going into tomorrow. Trust that you know the stuff. And what you don't know, you can either eliminate or logically figure out. Okay? Also know that if things don't go well, remember this is one test on one Saturday morning in April. I've been with you the entire year. TG does listen to what I have to say. Okay? So if you are, if you miss it by 5 points or whatever, come talk to me. I'll talk to them. We'll see what we can do. All right? All right, folks, that's how you math.
Don't forget to like and subscribe. Thank you.
Yep. How did I get back to that screen before? Where did I press?
No, just like, I don't even know.
Oh, there we go. Okay, now I can stop recording.